Good day, everybody. Brian here from quantlabs.net. This video, I want to introduce you to the full details right from this table of contents for this new free book called Low Latency Trading Systems and Overview C++ for HFT free ebook. So I put out a video last week for all those that opted in. Thank you very much. We're getting this out right away today. Anyways, if you want your copy, just go over to the link below, register, which will take you to here, and just sign up, opt in, and you'll get your immediate copy right away. Anyways, let's get to it. Um, First things first is I want to make sure we understand the scope of this book, which is really crucial. One of them, from people that never watched the prior video, will there be C++ coded as part of the book? Without code, I don't see any point. There are plenty of other books on the market that discusses the same thing. That may be true, but when you see this the table of contents, you see how vast this is. And I'll go into more details about this and what I'm proposing to do. So right now, in this prior video presentation, I'm going to make sure I repeat the caveats. So here's the caveats. This book uh, is not about coding optimization, system architect, and network design. They're all crucial. All well, it covers those topics that should at a high level, introductory level, basic level. It also goes over deterministic network paths, low latency hardware, and co-location with exchanges that are essential. So you'll see in the table of contents, we cover this, but at a very basic level. Also, HFT is a complex domain. So this book, it's over 210 pages now of just the basic stuff. You can imagine how big a book or a book series, how long it would take to go through with all the source code available. As I said, I'll talk about what I plan to do afterwards. So hang tight. So this book merely scratches the surface. It's not. It's a dive deep into specific areas for mastery with your own detailed research after consuming book concepts. So basically, you'll get the concepts, do your own research to find the details. A good place to start is always GitHub. So again, I'm needing to repeat this in another way so everybody understands. The code examples provided will not be concise and illustrative. They focus on the core concept templates without excessive detail. Just want to make sure we get that straight. To reinforce that, this is now the cover right here. This is what it covers. This book is an introduction on low latency trading systems. This ebook will cover the basics of low latency trading, the basics, so people understand that, as well as more advanced topics such as system architecture, network design, and trading strategy development. So let me show you the table of contents now. As I said, the table of contents go well over 210 pages. They're quite vast. So I'll try to go through this as I've been editing this forever for the last number of days. You can see here, we're up to 205 pages, but in total, 210 around there. Let's go to the beginning. So these are the table of contents. That kind of covers all the major topics you would expect in one of these type of books. But again, it's free, okay? Like you're not paying any money for this at all. So coming back to the free concept, let's see what it's about. So it's about foundation, of course. What is low latency? Um, Understanding the latency, importance of speed, and role of technology, the critical aspects of low latency, and obviously focusing on the pros and cons of HFT, what it looks like. That's one of the interesting things about this ebook. It covers concepts when it comes to specifically machine learning that a lot of books have not covered that I've seen. on the new way of machine applying machine learning in the world at HFT. Of course, this book can be outdated fairly quickly the way things are going, but it's still good enough for foundation. So let's continue. Okay, so now that we've got the new specs applied, let's continue. Um, so we're going to talk about the basics of the trading systems coming from either C++ or Java. As I said, the language of choice is always going to be C++. So that's where you'll see most of the examples. But I just want to give a comparison between both Java and C++. So if you're wanting one of those high-paying jobs, these are the languages you'll need to know. More importantly, the language to know, as I said, is C++. So how do you know which one's the right tool for you for C++ versus Java? I talk about it from a couple of paragraphs of each: performance and speed and hybrid approach. Also, we talk about the key language for HFT. I also do branch out into MATLAB and Simulink for the FPGA. I base it on my experience. That's probably the easiest way to learn those concepts, but I do have a section on C++. I also have a small section using Python as well. Okay, so then we get into the computer hardware and networking, and we get more into the specifics as we move along. So we understand the memory hierarchy, very key to understand about the different levels of cache, memory allocation, deallocation, memory access patterns that are available, persistent memory, and specific considerations for C++. So if you're already lost, remember, we're just over 10% of the way through this book. This is also to introduce you to how complex these systems are and how they're developed. That's why these folks that develop and specialize this in certain areas of not just quant, also C++, hardcore development, I guess we call it, for these type of systems. And you can see why they get paid big dollars, because it's just all about complication. And again, I've mentioned this before. If you're new to programming, this book is going to be probably a more advanced book for you. So understand programming, specifically C++ as well, because it will really help you lump this and understand it easier so you won't get frustrated. Okay, so now we talk about architecture and the networking fundamentals. Obviously, you got software architecture and network architecture, hardware foundation. And again, I mentioned about the C++ coding examples. These are very, very basic and very primitive. One example, market data handler with performance optimization and other considerations. Building blocks of low latency systems, there's a lot. So we talk about order books. This is considered the heart of the HFT trading system. There's the different data structures and algorithms used specifically for order books. We talked about order book structure, data structures used, and there's pros and cons of each one. Consideration for the order book, additional areas of optimization. Again, we continue with the order books, understanding the order book itself, core data structure, hybrid approach, and so on. Then we look up how do we do fast lookup and update an algorithm? Because a lot of these systems are built around the algorithms themselves. Plus, there's a back end of it as well, using an AI concept maybe, or maybe building in a monolithic system. Nobody knows, depending upon how you want to build these things. Order book data structure, fast lookup, algorithm optimization. Then we get into the time complexity analysis. So again, there's different ways to build strategies for these. We have critical data structure, algos, optimization techniques, so on and so forth. Thread management, another very complicated way within high frequency trading systems, specifically at C++. So we have to understand threading, key considerations, C++ threading, using the standard thread, uh, synchronization, pools, challenges, and considerations. Now, again, I said that we will also show other examples in Java, which we will. thread basics, thread pools, challenges in HFT thread management, synchronization, thread local strategy, and performance. Okay, this is an important one, which I can confirm from other trading systems that I know about and how they've been developed specifically from, and has said this before, look up on my channel, Quant Labs, London Quant. From that person, this is key to his system and made him uh, basically change his life. All right, lock-free programming. That's the concept, lock-free programming in HFT. You have to understand it, understand atomic operations, lock-free data structure, challenges and consideration, lock-free order books, hybrid approaches, and performing performance evaluation. One thing here you have to understand in this book is it mentions a lot about understanding not just the software, computer science perspective, you also have to have a deep understanding of the hardware, specifically on the network cards, the operating system, along with the hardware as well. So in here, you'll see what I mean when we start to talk about FPGAs and GPU performance. So again, we talk about parallelism, C++ and parallelism, different algorithmic techniques with parallelism, some coding examples, again, parallel order matching. So again, very, very basic, very high level. I don't go too deep into it. I do in the comments give you the steps. And then if you want to learn more, that's why I say go out and learn that using something like GitHub. If you stay, if you hang out in this video, I'll explain what I'm proposing to do to go through all of this. And if you want to know what I'm going to do, as I said, stick it out in this video. Okay, so we've got here C++ parallelism, order matching, again, using parallelism, and how to measure performance optimization, or how to optimize it even better. Then we get more into the low-level memory management and optimization. There's obviously different options here for custom memory allocation, standard allocator, building your own custom allocator, using memory pools, different techniques you can use to consider for HFT, additional optimizations, challenges, and trade-offs. So again, we get more specific here, memory pooling for HFT and C++. We understand the basic memory pool, the memory pool techniques, challenges, and considerations, different best practices that are out there, and the additional optimizations. Again, we're not even halfway. I'm not saying that to discourage you. This is why, again, people get paid very, very big money to build these, know these, and master them, knowing how to get through these. Okay, so this is a big important element of C++ versus Java, garbage collection. It's known, and this can apply also to .NET or C#. Garbage collection pauses in high frequency trading. Nobody can control that. Maybe I think in the more modern versions, you may have some control, but this is why firms use C++ to have more control over their garbage collection. So you have to understand the problem, why C++ with its advantage, understand the different memory management strategies, because you're now handling your own memory. It's not just using a framework from the basic standard features of Java or C#, let's say. You have to build your own memory management. So you can use a memory pool, additional considerations and challenges and trade-offs. You can also use shared memory for optimal high frequency trading. Understand it, implement it, challenges, considerations, optimization, and advanced techniques, and the shared order book. That's kind of like in the concept of multi-threading as well. Again, another thing that's going to be important is message queuing for optimal high-speed trading. Again, C++. Understand the message queue, understand the POSIX, POSIX, that's standard Linux, message queuing, the challenges, considerations, advanced techniques, and alternative message queuing systems. One that comes to mind that I like and have always liked is Redis, as an example. Network sockets, optimal as well. Understanding the network socket programming, C++, optimizing socket performance, advanced techniques, challenges, and considerations. Core concepts for high frequency trading. This is another important element. Handling market data. So now we got to deal with parsing, normalizing market data, understanding the feeds, parsing the data, normalizing it, optimizing, handling different types of date formats or data formats, error handling, and validation. That could come right from the exchange. That can also be done through FIX or itch protocols. Hopefully we still have you. Efficient storage and retrieval of market data for high frequency trading with C++. Understanding market data storage requirements, data structures and formats, implementation in memory storage, persistent storage, indexing and queuing, and optimization techniques, and other considerations. Okay, so here's another interesting one about tick databases. Understanding the tick data structure, implementing it, using something called a circular buffer, data compressing, indexing for efficient retrieval, persistent storage, that could be stored in KX's KDB Plus database. I highlighted them a while back in one of those videos with an interview. Additional considerations and challenges and trade-offs. Okay. So now we're coming up to halfway. Now we're getting into order management systems, order types, life cycle of them, common order types, order life cycle, order structure, OMS, order matching, risk management here, performance optimization, and again, additional considerations. Okay, so now we go back in the order book with very specific discussion here. Order book structure, order book operation, optimization, matching. This is the key one right here, the engine matching, which is very important, especially if you're pumping thousands of trades per minute, per second, I should say. Yes, that is a thing. Advanced considerations, trade-offs as well. Okay, now coming back to the matching, pricing, engine basics, the book structure, matching process, optimizing considerations, and of course, trade-offs. So here we need to do some pre-trade risk checks. There's a core and the implementation of it, using some kind of framework, integrating it with an order management system, advanced risks, challenges, and all the like. Now, this is really important once you start to have open positions and exposure calculation. This is part of risk management. Position tracking, exposure calculation, risk management metrics, advanced exposure calculation, performance optimization, challenges, and considerations. Now, this is important in case when you have a meltdown internally in your system, you will want some form of circuit breaker or a kill switch. So we talk about both C++ implementation of one, challenges and consideration. Now, the trading strategy itself. It's not as complicated as you may think, but that's where the quant techniques come in. So you'll need to build some kind of core component trading system framework, implementation outline, development and the back testing of it, the strategy type, challenging and consideration, and some advanced topics. These type of things you need to understand is a lot of this is homegrown. A lot of these type of components that we're talking about in these systems are basically uh, talked about and they're homegrown. So they're not using any third-party framework whatsoever. Core principal strategy interface design, optimal high-frequency trading. So we have our strategy interface. We do not go into any form of strategy development here. This is just how to build a system that will provide some kind of framework that you would use to build out your custom strategy. That's another separate discussion. Strategy interface, implementation, the strategy manager, life cycle, advanced consideration, challenges, and best practices. Okay, now this is another important one a lot of people use and put a lot of time into. Specifically, they're building it out in Python. So backtesting engine, understanding the backtest, core components of the engine, C++ implementation outline, data management order book, simulating, strategy execution, performance metric, risk management, optimization, challenges, and considerations. Wow, this goes on. So now you have to monitor your strategies, the open ones, see how they're performing. So we have our deployment monitoring as well. Talk about the deployment process, coding example, strategy monitoring, performance monitoring as an example. Again, very basic, high level. Version control and configuration management. That could be if you wanted to use GitHub. I wouldn't trust GitHub storing code like this that could be so valuable and storing it on GitHub. I wouldn't trust it. You probably want to have your own internal solution. Version control, configuration, A/B testing, uh, continuous integration and continuous development, CI/CD, challenges and considerations. So we've talked about high frequency trading. Now we got to get into more ultra low latency technologies. So this is more important, more valuable at high frequency trading firms and banks and hedge funds that get into this. This is very specialized. And you're going to get more into hardware. So this is what we talk about. Hardware acceleration, ultra low latency techniques. Also, how do you apply machine learning to it? And then once you get into this, depending upon your situation, you may need to be uh, following through on regulatory compliance and market microstructure. So here we talk about hardware acceleration, key hardware acceleration technologies, benefits of it, challenges and considerations. So the first example, as I said, is FPGA basics. Understanding an FPGA, key component of an FPGA, FPGA and HFT, C++ and HFT, design flow, challenges, considerations. So as I mentioned earlier, I've kind of played with this using MATLAB and Simulink. If you find using C++ is confusing, you can use MATLAB for this. It's a very expensive option, like 40,000 from what I remember 10 years ago. It might be more expensive now. But we're getting into the deep nitty-gritty. But usually they charge this much because you're probably going to be starting off with a multi-million-dollar account. So you're going to have cash. They know it. And it's no different than the market data feed. If you're sitting on an exchange directly, like a CME, you will pay for the data. There's no doubt about it. And that's into the thousands. If you're going to have servers sitting co-located right next to or in the exchange itself. So expect to spend big money. This is not for poor people. I hate to say it. So regarding Simulink and MATLAB, once again, understanding it, FPGA design flow, using the FPGA design within Simulink, how to accelerate it for HFT, how to integrate it with integration, and challenges and consideration examples as well, using, again, order matching. Here, I will tell you use Simulink and you can use a generator for both the FPGA languages of V, HDL, and Verilog. You also can generate assembler in C++. Not very meaningful. Last time I checked, that was 10 plus years ago, but the possibilities are there. Then we get into GPU, graphical processing unit, understanding it for HFT using CUDA. That's the most popular one from obviously NVIDIA. The GPU acceleration, optimization, and techniques. GPU accelerated order matching example again. So again, here we have ultra low latency frequency trading with C++ coding. Now, this is something new for maybe some people, including me. Network hard offloading, key offload features. C++ implementation using raw signals or sockets, optimizing network card performance, challenges of consideration, advanced techniques, and conclusion. So when I said about GPU, network card offloading, and also FPGA, and even in the ASICs world, this stuff is where you need to know the hardware. Again, low latency C++, hardware optimization, software optimization, coding techniques, network optimization, additional considerations, and again, another example, low latency order matching. Now, this is another option as well. This is the fastest, but it's going to have some errors in it, so be aware of that. You can do Linux kernel bypass networking for, again, ultra low latency, high frequency trading with C++. Some firms probably do this. They're not going to let you know, but you will need to understand that. There is not a lot of material out there on this, but again, you could probably obviously use your search engines and GitHub for the coding examples. So understanding kernel bypass, implementing again raw socket, challenges and consideration, advanced techniques and whatnot. And again, I want to stress this is basics. This is just to give you a taste at the high level on how this works. RDMA for fastest high frequency trading with C++ examples, RDMA hardware software, C++ implementation with it, optimizing and challenges and consideration. And there's obviously advanced techniques on that. And real world applications in HFT. Another one I've never heard of as well, precision time protocol, accurate time stamping in high frequency. So we understand that, how it's working in HFT, implementing the PTP libraries, challenges and considerations. Machine learning, everybody wants this. This is an important aspect that's a small portion of the complete enchilada of how everything works together. So here we have core application of machine learning techniques for HFT, challenge and consideration, integrations with HFT. And this is the key one, future trends. You may think you know the current machine learning, but this little section right here will talk about stuff that you don't know and what they're applying in HFT for the future. Feature engineering for market data, ultra low latency, high frequency trading. So again, ultra low latency. Feature engineering. That's kind of another form of machine learning. It's basically building ranks for feature types, feature extraction techniques, C++ implementation for feature calculation. So again, this is kind of like ranking. Feature engineering for low latency, advanced feature engineering techniques, challenges, and considerations. Real-time prediction modeling for optimal high-frequency trading with C++. So again, this is real-time predicting, another form of machine learning, but in real time. So we have real-time prediction models, model types, a simple statistic model, and they keep it simple for obviously optimal performance, model training, optimization, model deployment, and execution. Challenges, consideration, advanced technique. So this is part of one example, neural network for price prediction. So there is a decent section on machine learning here, but this is probably a more popular ways of how they apply it in the world of HFT. Reinforcement learning for HFT, fastest high frequency trading algos and strategies with C++ coding samples. So you can imagine if I was to actually build a system to show this or a system with full production ready code, this would be worth a lot of money. And I'm not talking a few thousand, because as is shown earlier, the complaining for a free book, and yet there's talk of this, which may not be talked about a lot in other books. I can't say because I don't read them. I have done comparisons, but they just cover basic topics. Here you're getting it all in one source. That's the one good advantage of this. And again, this is why this is free, right? So So reinforcement learning basics, RL algorithms for HFT, implementation, something called Q learning, challenges in applying RL to HFT, addressing challenges, integration with HFT and advanced techniques. Now, this is something a lot of people may not want to know, but I will tell you what I've seen and read. When it comes to regulation, especially in EU, you have to provide the source code to the regulators and get it approved. As bat crazy as that is, that's what I understand the latest regulation is. Okay, so I don't make the rules. I'm just delivering what I think are the rules, but understand how that works. But again, you can understand, research this on your own. So you have the regulatory compliance, market microstructure, and HFT, interplay between regulation and market microstructure, because the HFT stuff has a huge impact on the general trading ecosystem in the world. So here we have MFID, Reg NMS, which is for the US, for HFT. So we talk about both impact on the HFT firms, challenges, and opportunities. Okay, so now we talk about market access and co-location. Talk about both challenges, best practices, the future of market access and co-location. These topics on the future is what really makes this book valuable, I think. Trade reporting and audit trails. This again, you need to have for the regulators. Can't stress that enough. Importance of trading reporting and audit trails. Talk about both challenges and consideration advanced topics. So again, here we go more deeper. Trade reporting and audit trails for HFT and Python coding example. This is the sort of thing that Python's really good at. And I don't see any other reason why you'd want to use some other language. Python's good for this. Understand trading, reporting, audit trail, regulatory. Python is the only one you get with Python. Trade and audit data structure, data storage, retrieval, real-time data capture, reporting analysis, challenges, and consideration, advanced topics. So we're now about getting into, let's say, the last half of the book. System architecture, integration for HFT, core components, system integration, challenges, consideration, advanced architecture, and how to quote unquote simplify it. That's probably the key, even though it is complicated looking. Designing complete trading ecosystem in an HFT system with C++ coding examples. Components of an HFT system, ecosystem, because it's what it is. It's not one system. It's an ecosystem of systems. C++ implementation outline, system integration and data flow, challenges and consideration, advanced architects, conclusion. Continuing along, component interaction and data flow in high frequency trading. Core components and their interaction, code examples, simplified data flow, data structure, queues. So we're kind of all over the place, but it's all integrated, as I said, in one book. Low latency communication, challenges and consideration, advanced topics. One of these terms of low latency is using something called 0MQ. It's all open source. Fault tolerance and disaster recovery for HFT. Fault tolerance, we talked about each fault tolerance techniques. We also got disaster recovery and so on and so forth. So how do we tune the system? Use it hardware, software, network, algo, system level, low latency order matching. See, order matching is usually the most used example on this throughout the book. This is so important. Profiling tooling, techniques for HFT with C++ coding examples. So this is now more profiling and testing. Understanding what are your tools? An example using gprof. Profiling techniques, looking for the bottlenecks, optimization strategy, advanced profiling techniques. So here, if I stop here, this is going to take, if you were to do it on your own, it would take you a lot. So many months, maybe even years to complete this. I'm not saying it's not doable, but just give you an appreciation what's involved. identifying and resolving bottlenecks, common bottlenecks, profiling tools, techniques using gprof again, optimization strategy, order matching engine, case study, continuous monitoring and improvement. Monitoring the high frequency trading, importance of continuous performance monitoring, KPIs, basic performance metrics, monitoring tools and techniques, advanced monitoring, challenges and consideration. Testing and deploying, okay. So challenge and consideration, advanced topics, fine. Unit and integrated testing. So all the standard methodologies you'd use plus more, unit testing, integration, TDD, mocking and stubbing, continuous integration, continuation delivery, CI/CD, best practices, simulation environment. Okay, so I could go into detail on that. I'm not going to do that here. Role of simulation, key components of simulation, open source simulation frameworks, building custom simulation environment, again, simplified order book, deploying to production once you get there. Best practices by using a GitHub repository. Deployment process, the role of GitHub. Best practice for HFT deployment. GitHub repository structure. Automation tool, challenges and considerations. So here, we get into the real world stuff. Looking at technology stack, real world examples in GitHub repositories. There's a bunch you can look at. They're open source projects as examples, challenges and considerations, best practices, so forth. Lessons learned from industry implementation for high frequency. Importance of ultra low latency. So we already talked about those topics. Role of risk management, significance of order management, execution. This is kind of recapitulating everything already mentioned. Power and data analytics, regulatory compliance and the market impact. That's important. That's why they have heavy regulation, because of the market impact that these systems can have on the entire trading environment. Human factor, lessons from failures, future trends in HFT and low latency trading. This is valuable right here. Advance in hardware networking, evolution of trading algos, regulatory landscape and market structure, challenges and opportunities. Okay, so I went through GitHub looking for C++ and Java code examples. There were a few here. So we got core components, C++, Java code, GitHub repositories, and key consideration for low latency. They exist, but they're not all all inclusive. There's bits and pieces, but here I do my best to show you those examples. So we have a glossary for all the trading terms for HFT, advanced technology infrastructure, risk and compliance, and additional terms. So I've given you some other books you can look at for blogs and other free resources. So that's pretty well it. It's a lot, I know. But here, again, if you want to know more, full places to go. Make sure you go to quantlabsnet.com, click that learn, and then there you will get your C++ HFT ebook. Plus, if you're interested in the easy way, TradingView as well. All right, so what more can I add? But that's pretty well it. Understand the caveats, as I said at the beginning. Have fun with it. Go get them. Sign up for the book. It will be ready tonight, next few hours. And if you don't hear from me, get in touch. I'll send you out a copy. Over and out.